Good evening, everyone, or good morning, or good afternoon for you, whatever time zone you may be in. Welcome to yet another live stream about Pokemon and data analytics. Or maybe I should say the other way around. Data analytics about Pokemon. Because we are obviously not just looking at Pokemon. We are looking at the data behind Pokemon. I've installed a new way to play music, which is copyright free. So I hope that you guys still enjoy the music, but that I don't get penalized on YouTube for playing copyrighted music anymore. And I suppose that is the very big news, is that my previous VODs from Twitch, as they do disappear after 7 days from Twitch automatically, I have now started uploading them to YouTube so that you can watch those in full on YouTube. Usually 2 to 3 days after the stream, they should be up there. So I'll just paste my link to the YouTube playlist in chat. It's also in the About section on my profile. Do leave a comment on those videos if you have some feedback. Try to make the thumbnails a little bit interesting and not just pick one from the video. But I'm no interaction designer or UX designer, so they might not look that pretty. But that's secondary. We are here today for more Pokemon and more data and more analytics. So let's jump right in and pick up where we were last time. Where were we last time? We were stuck. We were stuck on Pokemon types, specifically about merging two types. And the reason we got stuck is because each Pokemon has one or two types, like grass poison, but those two types can be in different order, but the order doesn't matter. So I had to find a way to make that work, and I spent some time doing that over the weekend, and I have found a way to make that work. So we can not get distracted anymore about that, and I will show you how I made that work. We can also look into the correlation stuff again. Sort of normalization and stuff is a little bit over my head still. As I said, this is also a chance for me to learn things, and I by all means don't know everything. So if we want to experiment a little bit about normalization, that's fine. I would probably just do a standard min-max thing there, where we can try and figure out if the correlation is relevant for the base stats. And then we can move on to the really interesting stuff about what takes most least damage. Can we build a dream team of Pokemon? And if you're here watching, do let me know in the chat. Love to know where you're watching from. What made you interested about this stream? Was it the Pokemon? Because I know it could be the Pokemon. But hopefully it was the data analytics part, because that's the part I find very exciting. And it's just a little sweet bonus that it happens to be about Pokemon, which of course I love, like a lot of games. I'm also a very big gamer, and I might be streaming games on Twitch one day, who knows. Yeah, just the usual disclaimer about the data set that I said last time. It might be slightly out of date because of some DLC, but it does account for all 8 generations of Pokemon, and we'll do a quick rundown of the data set so you can see it. All the data fields are here, which I might come back to later to reference if we forget something, but should be relatively straightforward. Hey Sharpclaw, thanks for joining. Are you going to be streaming today as well? We're not competing with each other anymore, at least for SQL. I see you've moved on to bigger and better coding languages. So yeah, I think we will dive right in. How about that? So this is my empty JetBrains data grip editor. Why is it empty? Because I don't want to reveal too much. There's a query here ready for us to go, but I don't want to reveal too much. What I do want to reveal is what we've done here. So last time we imported this data set, and do let me know if music is too loud or the text is too small or whatever. Just let me know in chat. The dataset we have about Pokemon contains all Pokedex numbers from 1 to 890, I believe it was. We have a code, which is kind of like a variant because some Pokemon can appear in different forms, such as Venusaur. Can appear in different forms in the game, and this variant code accounts for that form. And we have a serial, which is basically a unique identifier for each Pokemon. It's the Pokedex number times 10 plus the code, which ensures that it is unique across the entire table, which is fantastic because we can do count distinct Pokedex number or count distinct serial, and then we can find out how many Pokemon there actually are or how many Pokedex numbers there are. So how many Pokemon in how many variants and all that kind of stuff. We did that last week, so you can go look at that on YouTube or on Twitch if you're interested in seeing exactly what we did. But we basically got stuck on this type problem. The type problem is grass poison can technically also appear as poison grass. And the issue with that is that both are the same thing for, let's say, data analytics purposes and attack stats purposes. They are the same. And so I had to find a way to get them cleaned, and you can see here there's this type cleaned field, and that is the field I have added to this data table. And when you see the code for this, you will laugh because I was trying to solve it, and it was very, very difficult for me to try and solve it in the stream. We had like 20, 30 lines of code with case whens and reversal stuff and all kinds of stuff. And in the end, it's actually just a one line. And I'll just explain how this works. So there are these two fields here, type 1 and type 2, like grass and poison, for example. Now, if you don't have a second type, that's the first thing, right? There are some Pokemons that are single type. They're just fire, for example. So what we want is if the second type is empty with null, then we just output type 1. And that's the cleaned version, right? Otherwise, what we're going to do, which means they have two types, we're going to try and concatenate them together. And what I was trying to do last time was trying to flip them around the other way around and self-join the key and stuff like that, and that doesn't work. The reason it doesn't work is because reversed grass poison will never match poison grass. They can't match. It's not possible. And so it's maybe on some technical level with some formula that I don't know about or some function may be possible to duplicate that you have grass, poison, and then grass, poison, grass as some kind of mapping table. But that's super complicated. In the end, I found a solution, which is fantastic, and that solution is to use a alphabetic sorting of the type values. So basically what I do is do a concatenation of least and greatest, which is a min-max for non-integer values. And non-integer means basically string, because these are strings and not numbers. We can't do min-max. But we can do least and greatest, and what that does is it concatenates everything in alphabetical order, which means that Pokemon who are actually water bug, let's do a little, let me just do a little search here for you. So I'm just going to open a new console here. So if we have type 1, type 2, and type cleaned, where type 1 equals, let's do in. So I'm just selecting the water and bug combination because I wanted to show this, how it works specifically. Type 2 in, I can just copy that. Yeah, so basically, if I have a Pokemon that is bug water, it will be output as bug water. But if I have a Pokemon that's water bug, it will still be output as bug water. And that is the solution to having all of these 5 Pokemon treated as the same type. And that's what we want to be doing. We want to be treating them as the same type. In reality, they're water bug. In reality, they are the same type. It's just written the other way around. So yeah, that was pretty lovely to figure that out, which means that we can actually start by doing cool stuff. Case in point, something I just did before. I'm just going to explain it briefly. So if we take this type, and the ones that have slashes in them, we know those are dual type Pokemon. So actually we can just make a small case when statement here and say if there is a slash, we don't even need this technically, if there is a slash somewhere in the string, then they are dual. Otherwise they are single type Pokemon. And we can just count how many Pokemon in the Pokédex, so serial, not by Pokédex number, but actually by Pokemon in all of their occurrences. How many are there? And we can group them, and we actually see out of these 1,041 total, we have almost a 50-50 split of dual and single type Pokemon, which is very interesting for me. It just proves that they've also somehow chosen to balance the game in some way. Or at least this would appear to be that the game is balanced. So if you're new to the stream, or if you're just joining now a bit later, just jumping in here directly about something we fixed last time. And so today one of the things that I wanted to find out, now that we have sorted out the type, was which types do most damage versus receive most damage. And for that we need to go back to the data set to better understand how we can even work that out. So let me show you here what this is. In the data set we have these 6 columns: HP, attack, defense, special attack, special defense, and speed. Those 6 columns together add up to the total. The total stat is basically just a sum of all of these. Now the total stat is what determines kind of the overall, I would say, power of the Pokemon. But it's not definitive in battle. This is what we're going to get to later. It's not definitive in battle because a Pokemon with higher speed would strike first, and it's a lot more complicated than that. So we are not doing battle simulations. That's way beyond what we can do with simple SQL. If we wanted to do battle simulations, we'd have to probably write some pretty extensive code to do that. There was a guy in the stream last time, on Friday, who actually did that, wrote battle simulations. I'm not sure what code he used, but it's fairly extensive work. What we're going to be doing is looking at which types take most damage and do most damage, and based on that information, we can assess how we would want to assemble our team. So we're going to not look at the stats yet. I think we'll look at the stats afterwards. It's something I want to do, to look at the stats in correlation with height and weight. But first I want to look at specifically these 18 features which have already been included in the dataset. Each of these features, so they have against and then every type of Pokemon that exists in the game. So there's 18 types of Pokemon. These 18 features can be described as the amount of damage, so aka as a multiplier, taken with an attack of a particular type. We have to be very careful with this. This is not about the type of Pokemon itself. This is about the type of attack that was launched, which is fine, but we can make some assumptions about which Pokemon do most damage afterwards. But now we're just going to be looking at which Pokemon take most versus least damage, because we are just looking at the incoming attack type and not the Pokemon that was launching an attack. So to make that very clear, Pikachu, which is an electric Pokemon, which I'm assuming most of you are familiar with because he seems to be one of the most famous Pokemon. Pikachu is electric, a mouse Pokemon. And Pikachu has, for example, against electric, 0.5, which means if an electric attack comes in against Pikachu, so another Pokemon does an electric attack, like, I don't know, Thunderbolt or whatever it's called, against Pikachu, then Pikachu will take half of the normal damage that that attack would do. And how that damage is calculated is too complicated for the stream to work out, or for me to work out just like that on the fly, but basically they take half of the damage. Pikachu, however, if it receives a ground attack, it will do twice the amount of damage. And all the ones with 1, they do standard damage, so no multiplier. So based on that information, we can do one of the following things. We can already start to classify the damage types. So we can see case, could do with a case when, against bug, or well, let's continue. Let's hear in chat, which Pokemon should we use as a case for the modeling? Because I have a favorite Pokemon. My favorite Pokemon is called Psyduck. I don't know if you know Psyduck. He makes I think he's usually male. He makes like this funny Psyduck. See, he's always holding his head because he's got a huge headache. He's my favorite Pokemon. But if you have another Pokemon you would prefer to model, do let me know in chat. I'm going to use Psyduck to model my query on. And I typically do this. I actually take 1 or 2 records out of the data set, and I model my query against that. Psyduck's maybe not the best example because he is only a water Pokemon. 50% male, so yeah, it could be female Psyduck. So I should be saying they would be the correct pronoun. But yeah, we can do one afterwards with a dual type, because it gets more complicated with dual type Pokemon. Of course, because they have 2 types and then they can take different types of damage from different sources of attacks and potentially twice as much or twice as little, if that makes sense. So compounded, right? So we can do basically a matrix of disadvantaged, advantaged, or basically no advantage or no disadvantage attacks types, because we have the information here in this against. So I'm actually going to do this a bit easier. We're just going to do type cleaned. I have too many columns. Against. Oh, come on. Against bug, for example. What else have we got? Against dark, etc. Oh yeah, I have an error here, sorry. So we have here like, so Psyduck will take one like normal damage from bug, normal damage from dark attacks, etc. And so what we can do is instead of just listing these, we can actually summarize them. Now we have to do this 18 times. Rather, well, we need to do this 18 times 3 conditions. But I'll show you a really quick way of writing this. So when against bug is less than 1, then we're going to call this disadvantaged. Or no, let's call this advantage, because they're basically an advantage for the attack that's being launched against them. When against bug is greater than 1, then we're going to say they're at a disadvantage. Disadvantage. Let's say I don't know, that's very confusing to read it this way. Let's say div. And else it's going to be normal, right? Because there's only those 3 possibilities. And we're going to end this query as against, let's say, bug damage type. You can abbreviate everything because we're going to have 18 of these columns, right? And so you're wondering, how are we going to write this condition out 18 times without going crazy? Basically, we can copy this 18 times, like this, right? So that's one way of doing it. This is the way I'm going to do it today, is copy it out 18 times. So I just need to make this smaller. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. You're not meant to be able to read it, by the way, in case you were trying to read it. And what I'm going to do now is these features here, these against bug, I can change both of them at the same time to change them like this to against dark. So all I need to do is all I need to have is the original table below me, which I can actually do by splitting this screen and then transposing this like that, so I can see all the names like this, I think. I guess you guys can see this. So just make a little split screen. I can even move this over if I wanted. And now, so against dark, and then all I do is just change this. So I don't need to write too much differently, but we're gonna have to write this out. So give me a few seconds to do that. In the meantime, if you're here, do let me know in chat. Would love to know where you're tuning in from. At the moment, it's just Pretzel writing in the chat about what music is playing. So this is something actually new that I've started. I saw it on another streamer's stream that they had this Pretzel Rocks as a copyright-free music option, and I took a quick look at it, and it's actually pretty cool. So that's what I decided to start using as well, so I don't get any strikes against me. On here on Twitch anyway. As the channel's not monetized, it's not an issue. But as I am uploading the VODs to YouTube now, YouTube is telling me, oh, this is copyright, this is copyright, might be blocked in this country, etc. So yeah, that's something to avoid. And I mean, playing copyrighted music without proper attribution is not great anyway. So Svene, nice to see you again. I know you were in the stream last Friday as well. You're only here for the Pokemon and not for the data analytics. What a shame. But that's okay, I understand. Let's see, grass. So we are currently mapping all of these different types, a little bit boring, into these case when statements. And the idea is that we will then have for each type, so distinct type combination that there is, of which there are 150, by the way. So there's 18 types of Pokemon in the game, right? And if every type existed in every combination, it would be 18 times 18 times each order. But obviously also with the single versions, so there would be 183 permutations, I think it is. But as it turns out, there's 153 unique combinations once you've taken out the ones that occur multiple times in different alphabetical order. Svenne, which is your favorite Pokemon? Do you have a favorite Pokemon, or do you like all 800 something equally? As I said, I quite like Psyduck. I've also been a huge Mew fan. It's just one of those, I think it's more nostalgia than ability of Mew, but it's just one of those things. Trying to get Mew so long ago on Game Boy. Can still remember the struggles. So we only got 2 left here, we're almost done. So against Steel. And the last one is against Water. Beautiful. So now we have these clusters. Or clustered. We have clustered values because we only have 3 possibilities. We have normal, disadvantaged, or advantage. Again, advantage means the attack does less damage, and disadvantage means the attack does more than 1 damage. And this is very interesting because if we take the condition here out for a second, and let's just, we'll get to this afterwards. If we do this for all Pokemon in the database, 157 rows. So for every single type now, we have these advantage and disadvantage. This is pretty cool. What can we figure out from this? We can figure out a few different things. First, what we need to do is make space. And I mean literally just make space on the screen. So we're going to do distinct star to get all fields, and then I'm adding these fields. And I'm going to call this, I don't know what we should call this. Type class for classification. So, and then we can do select star from type class. That's odd. Doesn't like this. It should not be arguing with me on this one. Okay. Not sure what the error is here. Oh, right. Alias. We always need an alias when we write a common table expression. We always need to write the as, so the alias terminology. And see, now we've cleaned up. We don't have to worry about that anymore. And we get the same information. We just get everything here. So we get all this information. So what we can do is we can start to group them based on, for example, how many of them have disadvantages and advantages. So we have to count across multiple columns how many times advantage appears. So let's see here. We could probably do... We can start experimenting a little bit. So serial, and then where's this? We can actually output all of these very easily like this. And then we can take out all the other fields. Auto-completion is a lifesaver, honestly. Can format briefly. So if I just have the serial and that information, then I just have each Pokemon, essentially each variant of each Pokemon. Because the variants are actually important. The variants have different types in some cases. So that's very important that we account for that. So in reality, there's 1,041 Pokemon, unique Pokemon, if you will, rather than just this 892, I believe it is. So what we can do is we can try, for example, with bug DT. So what I would do is I would want to count when they have advantage, when they have disadvantage, and basically kind of make a strike list. So I would do case when bug DT equals advantage, then 1, else 0. And I could count this or make a sum. Let's see. This is a little workaround for a case when you can actually make a sum of different case whens. Just working out here what the best way of doing this is. So if we have an aggregate like that, let's just comment these out for the moment. We will need to group by. Oh, and nobody told me my query was not capitalized here. That's not very nice. So we have a syntax error because we have a comma here. All right, so we have basically 1, which would give us a count. And if we didn't include the serial, then we would have the sum of all of them, which is what we would want, for example. So that makes sense. But this would only give us the advantage case. Let's see. Maybe we can do something funny. Like, does this make sense? So if bug DT is disadvantage, then -1. So this is like, in a way, a little bit of normalization. Maybe it's not the perfect one, but so we could do something like that. I suppose we could have done this directly out of the original case when as well. So instead of advantage, disadvantage, we actually could have written 1 for advantage, -1 for disadvantage, and then 0. But I need to count across multiple columns, because you see, the thing is, we have basically 18 different features, right? And I'd like to count across all features how many advantage they have, how many disadvantage they have, so we have a bit of an idea for each type cleaned, how it performs. So if I show it like this way, basically for each type, well, I have to make it distinct here. So for bug DT is normal. It's a one-to-one relationship. Bug electric as well, but bug fairy, for example, has an advantage against bug attacks. Takes less damage. Let's see. Maybe it would make sense to do this visually. I could also do something visually. I would need 1 second to get this set up. But we could actually visualize this in Metabase. Maybe we should do that. Would be interesting to do that because we have a full table of all of this information and we can actually color code them. So why not? Why not? Why not? Let's do that. Instead of these strings, so instead of advantage, let's see if I can replace all of them. Find, replace. So find advantage, replace with, oh, I need to do single quotes as well. So we're gonna find all usage of advantage and we're gonna replace it with 1. So that's good. I just replace all. And then we're gonna find all the usages of div and we're gonna replace with -1. And we're gonna find all the usages of normal and we're gonna replace with 0. All right. But it's a bit silly because we had also the raw numbers, but I think this is an easier way to just see it visually in one go. That's just my opinion. Let me just double check here that I can get Metabase started. I have to also get it running in my localhost container on Docker. And I'll also need to bring that in here in the streaming software because I don't have that yet. So let me just do that 1 second. I think it will be useful to see it this way, to be honest with you. All right. Can make this a bit bigger. All right, there we go. That booted up quick. So if you're watching the stream, it should have changed to a blindingly white screen, which is Metabase, which is a little software for doing business intelligence. And we can see this, that you can actually write SQL directly in here. So I'm not writing SQL directly in Metabase because I don't want to visualize everything that I do. Some things I do, some things I don't. But it is very useful if I want to visualize something, then I can do that. And there's no heat map option here. We have to find the right visualization that makes sense for this case. Heat map would be useful. Why don't we do that? We could actually do a heat map. We could do that in Google Sheets, right? So I'll just copy this to my clipboard. And then I should be able to just paste this in here. There we go. Let's see here. There. No, that's not the one I wanted. Oh. You. So what I want to do is I want to split the... Oh, here it is. Split text to columns based on semicolon. Does that look right? It does, yes. So 158 types, unique. Now we can sort this entire thing. So data, sort by column A. Oops. We need to tell it that we have headers. Otherwise it doesn't know. Data as a header row, type cleaned A to Z. This will make it a bit easier to see. And because we don't care so much about the numbers themselves, but more the visual, we can leave it this small, I think. The list is a bit long, but let's see. Some things are just easier in a spreadsheet than in an SQL tool, in an IDE, and I think good data analysts or people working with data, they understand that. So now what we can do is we can just apply conditional formatting here. You could do this in something like R, no doubt. So if we say it's, well, we can do exactly, actually. We can do exactly -1 will be, let's say, red. That's fine. Make another rule. If it is exactly 1, we will make it green. And we'll leave the zeros out for now because it doesn't actually have an advantage or a disadvantage. So let's see here. Across all 18 types, right? So visually, there are a few that stand out. And remember, we have to be actually looking, we have to be looking across and not down. And the brain is actually wired to kind of look downwards. So one thing we can actually do is we can actually transpose this entire information. Oh, I didn't want to do it that way. Let's try that again. Select everything, copy, and I'll make a new sheet just in case I mess it up. Transposed. There we go. So now that we can look downwards because each type is its own. And I don't know, there's some types, for example, dark grass seems highly disadvantaged. Or let's say highly disadvantaged but also advantaged. What we could do is actually maybe average these out. Average. Let's average them out. Something we could have done in SQL too. So unfortunately there's a lot of columns. And so these are the averages. And now it would be fun to sort the columns based on that average. So again, we're going to have to go back to this because we can make the average here. I don't know, average DT. I'm going to make the average from here to here. Oh, what happened there? Why is it telling me it doesn't like this? Circular dependence. Oh, oops, I went too far. I included S. There we go. So now we have an average DT, and now we can rank all of these. Let me just zoom out a little bit. Where's the zoom thing here? I missed it. There we go. So now we can actually, instead of sorting by can actually put it in front. Instead of sorting by type, we can actually sort by the average DT. Oh man, I really don't like this sort range stuff in Google because you always have to tell it has a header, otherwise you don't know. So, okay, these are the, let's say, by this definition, worst Pokemon types. So I just truncate this to like 3 decimal places. So fighting ice is apparently a terrible combination because they will take, at least across all 18, tendency to take negative damage or more disadvantage attacks. Let's not forget this doesn't account for the strength of the disadvantage. That's something we can still do with the raw data after. But technically speaking, fighting ice doesn't do so well. So I'm just going to get rid of this sheet. Type class damage. So fighting ice doesn't do so well. So these are the negatives. These are marginally negative, these ones. They all have, interestingly enough, very similar values. These ones are kind of in their own band here. And then there's fighting ice, which is really an outlier. This information would definitely be plottable. We could have a little bit of a visualization about that in particular. We could plot this on a nice histogram, which gives us, yeah, like basically, oh, come on. I clicked it, I didn't really want it. There we go. So we get a nice little average of the values here. So we can see that generally speaking, the balance is good, but there are quite a few that are in this region down here. There are quite a few that are actually have a tendency to have an advantage. So they will tend to take less damage. So that's what the advantage means, right? That's kind of interesting. I would have thought it would be a bit more balanced, but I guess it's quite hard to do, to be honest. I mean, I'm no game designer. What do you guys think who are watching? Do you think this is deterministic for the balance of the game in some way? I mean, I think that it's not bad, certainly. I mean, the bulk of the Pokemon types are within here. What's interesting though is this is just the types of Pokemon, right? This is not actually based on the number of Pokemon that exist of each type. So this is something we should probably do. So let's go back. Let's go back for a moment to our query. And let's add in a, let's call it participation rate for Pokemon. Or what would we call it? Not participation rate. We would probably call this something like a spread or occurrence, like an occurrence factor, although it's not a factor between, I guess it's a factor between 0 and 1. So we would have like this occurrence factor, and the occurrence factor would be basically, so there's the type, right? But we also want to count the number of Pokemon that occur of each type divided by the total, which is 1041. That's why we can keep this as a fixed number in this case. And if I add a .0 here, so in previous streams I've been showing that if you do a division with an integer, you will just get an integer value. Oops, sorry about that. I'm going to need my group by statement. What I'm going to do is going to move this all the way to the bottom. Otherwise I need to group by everything. Or I'm gonna need to group by everything, aren't I? Yeah, okay. There's probably no way around this. But basically, you have to, if you want to do division, then you will always, if you divide by an integer, you will never get anything else than an integer, which in most cases is going to be a rounded up number or something that's completely incorrect. So you can add either float to one of your two types, which creates a decimal, or you can do the fast way and actually just add .0, and that does the same trick. And I learned this trick from DataCamp, which is like Code Academy or Udemy or whatever, all of these course providers. I've been doing some SQL courses on DataCamp to just make sure I haven't missed something, let's say in SQL, and also to level up my own SQL skills once I get to the more advanced stuff. And I learned this from that. So it shows you that you can always learn something new. You should never assume that you know everything. It's a very dangerous assumption. So we have this occurrence type, which tells us how often this type occurs in the entire spread of the Pokémon. And this is very important. So I'm going to copy this to the clipboard, and we're going to go back to the browser here. And so I unfortunately need to redo this a second here. So we're going to split text to column, semicolon. I need to sort the range by A to Z. Then I need to sort range here by A to Z by type cleaned, so that I don't mess up the order. See, in a normal database, we would just do like a join key and stuff like that. And I could definitely do that with VLOOKUP, but I am not going to do that today. It's so much easier just to take this column now and paste it in here. There we go. And I'm going to show you why this is important. So we have a type occurrence. Technically speaking, this should be 100%. That's right. And now we have, oh, that's very interesting that steal occurs twice. I think that's a mistake. That's a bit strange. I've only just seen that now. That steal is in there twice? Is that a formatting issue? Just gonna check. Yeah, interestingly enough. So this probably happens because one of the variants of a steel Pokemon, T-A-Day, or there must be a better way to pronounce that. Thank you very much for the follow. Do let me know if you're watching the stream as well, right in chat. Yeah, so this occurs, these double entries of steal actually occurs when one of the two variants of steal, so there will be different variants of the Pokemon in the deck, and one of them has a different stat than the other, and that's this one here, which is Ghost, I believe. Yeah. So that's a bit special, but it is also still important because it means that there are some Pokemon in Steel that are slightly better than other Steel pure types. But anyway, let me show you this. So this is not the best setup for this. Let me just customize this. Histogram, that's fine. Series. How do I get the second axis here? I can only do that with... Okay, I can only do that with combo chart. So I can't do a histogram combo chart. But I can show you at least here, visually, what I'm trying to say is the occurrence of these Pokemon, whichever type that is. Maybe we should have... Well, there's a few different types in there, obviously. But basically, the ones that have this 0.01, which is a slight disadvantage, are very common. Because this is... Oh, wait, this is a count, though. We should actually be doing a sum. Hold on a second. I'm not sure this is 100% correct. Type occurrence factor. Yeah, probably. It's a... Well, it is a count. I'm a bit concerned about how many values are in there. That's why I would prefer for it to be a sum, but I don't think I can do that. So we're going to do then combo chart. So this is what I want to show you now. With no stacking, we are going to put the type occurrence factor, which is the percentage. We are going to put that on an area. That's going to be on the left axis, and the average is going to be on the right axis. And I'm going to make this into columns. Is that... Nah, it's not so visible. Wait a second here. Let's do it the other way around. So the type occurrence factor, because it doesn't go into the negative, is going to be columns, and the average is going to be a line. That's a little bit better. All right. So visually speaking, I hope this tells the story that I want it to tell. Essentially, can I move this further up? I can also just put this on another page, like this. Because the numbers themselves are not relevant. What is relevant is what we see here. And what we see here is the following. So the type occurrence factor is basically the frequency at which that type of Pokemon occurs in the entire Pokemon dataset. And I purposely not sorted it because I think it's a little bit more, I think it's a bit more visually exciting this way. Okay? We could sort it if we wanted by occurrence. That might make things a little bit more obvious in a certain way. But I think it's more exciting to look at it that way. But let's sort it just for shits and giggles. So we're going to sort it by the type occurrence factor. All right. So basically, as Pokemon become more common, as that type becomes more common, generally speaking, the average damage becomes more disadvantageous. Does that make sense? Basically what we're seeing is that really rare Pokemon can have really nice advantage against attacks, because they will have advantage, let's say, more often, which makes sense for the balance of the game. What is interesting, however, is that there are some Pokemon, specifically within I would say I'm going to insert a little image. Oh, I can't. Wait. Drawing. Can I just insert some kind of square? Like this? Wow, okay. No. But basically, within the sort of from this sort of area here, where Pokemon are not occurring so often in the data set, so they're like 0.5% that type, right? Less than 1%. We're not talking about like normal, for example, which is 7% of all Pokemon. We're talking about like less than 1%, right? It's obviously not many Pokemon have these types to begin with. The occurrence of the Pokemon would be something else that will happen. We'll definitely look at as well, because each Pokemon have a kind of like chance to appear and stuff like that. I don't know if we have that specific number in the data set, but that's something we could potentially look into as well, if someone found that interesting. Or let's say the capture rate, like what's the chance of you capturing that Pokemon, for example. But here we see that there are some Pokemon within sort of the mid-range that are still very attractive. For example, Steel, we can see, has a pretty good advantage. Bug Steel, Steel. What's the other ones here? Steel as well. So that's the Ghost Steel. That's very interesting. Fairy Steel and Electric Steel. Steel seems to be quite common in terms of advantage. Of course, we could also like mine this for each particular type and figure out which ones are also interesting. But so for example, Dragon Steel, that's the other data point. Is that the strongest one? So like the rarest one would be Bug Ghost, which hardly ever occur, right? But what's really interesting is that, for example, Dark Normal is actually less likely to take, is less likely to have advantage. Now, this is just weighing advantage and disadvantage as 1 and -1. What would be interesting now is actually taking the specific multiplier. So in our data set, we have the actual multipliers. Rather than taking these values, we could take the against values. Against water. Let's see if I can do this. I don't know if I can actually output all of them in one go. Let's try like this. Distinct against. There we go. So these are all of them. It's almost like a new query, right? But basically I'm just gonna take out all of these. Don't need those. We just want the type cleaned. And then get rid of everything here except the against values. Alright, I could just do it this way. These we don't need either. And then we want that last occurrence factor. Oh. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That's weird. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 19? Okay. Very strange, but could have sworn there were 18 before. Okay, maybe it worked anyway. So now we have these actual coefficients with 0.25 and 0.5. So they will all be positive. And we need to be careful because 2 means they take twice the amount of damage. So the lower the value, the better. But we can export this one and just head back into Metabase, into Google Sheet here. And so this is, that's the histogram. Let's make a new tab. So let's call this type class damage viz. So this is type class raw. So we're gonna paste values only, data, split text to columns, semicolon. So bold, because it looks nice. We don't need to visualize anything. We have this type occurrence factor, which is how often that particular type occurs. And now would be interesting, instead of doing an average of these, we might actually want to sum them. Because, or let's call it sum damage. Basically, if we had 1 across all of them, it would be 18. So we would do sum of all of them is 13.25. And so if we do not an average, but if we do 18 minus the sum, then this is the, let me think. So in a normal situation, they would have 18. So 18 minus the sum means if they have leftover, then they are at a disadvantage. Wait a second. No, they're at an advantage if it's less than 18. But we don't need to do the minus. But I don't know, it makes more sense to me to do the minus. What does chat think? Should we do the minus or not? I just think the spread is a bit smaller that way. So for example, Dragon Water works out to 18 exactly. Even though some of them do more damage, they take way less damage in some other cases, which means they kind of balance those out. That's why I think this is kind of interesting to do it that way. And then, you guys probably wanted to have it sorted again. Let's do some damage. Now let's sort by type occurrence again. Okay, so this is going to be the second variant of our chart. This one I'm going to leave in here, in this tab here. All right, column chart, I think it needs another combo. So series, type occurrence factor is very small. We're going to make that the line on the left axis. And the sum damage is going to be columns on the right axis. There we go. So what do we see? We see that Flying Steel, while very rare, has a very, very high disadvantage because they take a higher, they take more damage on average. I mean, on average, they are more likely to take more damage. Now, of course, the spread of attacks is not equal across all different 18 Pokemon types, but that's another story altogether. What we want to see here is, for example, ice rock, -8. That's fascinating. Let's take a look at the ice rock case. There should be somewhere here. Ice rock. So ice rock, -8, 1111, 4.5, 22, 242. Oh, I think it's the other way around. I think this is the other way around. I have to think about this again. Challenge me, chat. Does this make sense logically? If the normal situation is 18, because they have all ones across the board, if they have more than 18, it means they take more damage. So if I do 18 minus whatever value is here, and they have minus, oh man, we should just do this -18. That would be so much easier. Let's do it that way. I don't like working with the opposite situation. So we're going to do like this. Small update. All right. So if it's 0, it's fine. If it's minus, it's particularly good, because it means they're taking way less damage, which for Dragon Steel makes a lot of sense because it's the rarest occurrence factor in the game according to the distribution. And I mean, this is just a normal, this is completely normal and expected, this occurrence factor. Some types occur very, very rarely, and then there's a few types that occur a lot in the game. And so ice rock is actually like the worst type, basically. A, it's very rare, and B, it just takes, it has a potential to take huge amounts of damage. Which is again something else that we should highlight. That's specifically against, for example, fight and steel, where ice rock takes twice the amount of normal damage, compounded, again, twice. So, because fighting against ice and fighting against rock is twice as effective. We can see that fairly easily. If I look at fighting and I look at standard rock Pokemon, which would be somewhere here, you can see it's a 2. And if I look at ice, I can see it's a 2. So logically, if something is rock ice, it will take 4 times as much damage, multiplier. So that's pretty nasty. So if you are fortunate to find a Fairy Steel Pokemon, which is relatively rare, 0.38% of all types that occur in the game, you won't be so happy because it's likely to take heavy damage. But maybe it can output a lot of damage. That's kind of the other part of this story that we're not considering, which is very difficult because we don't have the we don't have the information for each attack type, right? We don't have the we just don't have that in our data set. So that's interesting, for sure, for me anyway. I don't know how it was for you guys, but I thought that was very interesting. So I'm going to call these the scribbles as usual, and I will place those for later. So that's an interesting excursion, and I think what we learned is that kind of the rarer the Pokemon type occurrence, the more likely they are to be better overall, which makes sense. And now we also know which Pokemon types occur with what frequency. So if we take out all these against, like this, group by 1, then we also have, sorry, let's order as well, order by 2 descending. We also have the frequency of, yeah, how often each type of Pokemon occurs. Does it surprise anyone that normal and water Pokemon are like each 7%? Not really. But this is, yeah. So there is a piece of information in the original data set. So we could do more with this damage thing, but I feel like we got quite a bit out of it. We got out of it what I would wanted to see, to be honest. Unless you disagree, unless you feel no, we should go deeper into this damage stuff. But I'm happy looking into that in one other aspect, which is this capture rate. Now, the capture rate of the Pokemon is not the same for each type. So we can see that, let me see here, group by, order by 1. The capture rate varies by Pokemon. So all of these Pokemon are water, but the capture rate is all over the place. So we could do like some bounding with like min capture rate, and like a max capture rate. Come on. Group by 1. Order by, yeah, let's keep the order, but not descending. I don't know if someone's written in chat. I don't see any messages actually. My thing lagged out a little bit, but I see Pretzel Rocks posting, so it's probably fine. It's just very quiet today. That being said, we can see, okay, so Bug, for example, the minimum capture rate is 45 and the max is 255. So the bounds are not always the same. For example, Bug Fighting, 45. The capture rate, I believe, the higher, the better. Let me just check. In the capture, the higher the value, the easier it is to catch. So let's remember that. That's kind of important because, sorry, I want to change the music. I'm sorry. I'm going to go into some chill pop stuff. Or there's nothing there. We could try maybe some this stuff. There we go. So Bug Fighting is super rare. I mean rare in the sense that it doesn't occur very often, and if it does occur, it's not that easy to capture. This doesn't account for breeding, which you can do with the Pokemon with the eggs and stuff like that, but it at least accounts for one of those things. So this spread of the capture rate, for example, Bug Ground, super easy to catch. Super, super easy. Bug Steel, super hard to catch. So this is interesting. We could definitely do something with this in correlation with the occurrence. Because we could do something like, so these are all the types. And we could probably do this, let's say just with dual and single type for now. It's something that I wonder. So when type cleaned has a slash in it, then it's a dual type Pokemon. Otherwise it's this single type Pokemon. fire, water, etc. And we're going to call this pk type. So yeah, the spread is equally among both, which is good. That's actually very good. It tells us that the game is fairly balanced. We also see the occurrence is like almost equal, 46%, 53. It's very, very close to being 50-50. We saw before with the against stuff in the Google Sheet, we didn't actually do a comparison of single versus dual type. But I think we saw, generally speaking, the single type are a little bit weaker. Let me just bring this up again. We saw that generally speaking, the single types are high occurrence compared to the dual types. Here, they're all on the right side of the graph. Here, like ice, for example, they tend to be high occurring with relatively, yeah, they can take a lot of damage, let's say. And the dual types are kind of spread throughout the rest of the data set. But yeah, I mean, at least I don't think it's something we really need to go into, or it's not something that interests me too much right now. So, important to hydrate. Sometimes you'll hear my water bottle squeak. That's something I'm going to be fixing soon. I'm getting a new water bottle. So we did a lot here with these against, with the 1 and the minus and stuff, which was very cool. One of the other things we wanted to look into was if we could build a team. So I don't think we have enough information yet to build a team. I would like to know more about the height and weight correlation to know if I should factor that into my decision. Like, should I take massive stacked Pokémon in terms of height and weight into my equation? For that, I'm just going to start a new query window to start fresh. And we are going to do maybe some type of normalization. So there's a few different ways we could do normalization. You see, this is the problem. With data, we always have a problem. Height, weight, total. So just to give you a short overview of this issue. These are different Pokemon. It's just 10. They have heights and weights, and they have a total value. The total value, as I explained before, is their entire attack value. I mean, sorry, it's their total stats, including HP, attack. Oh, what was the other stuff? It's here somewhere. Yeah, so HP, attack, defense, special defense, speed. That is the total. Now, of course, speed and stuff determines like who attacks first and things like that, but we're not looking at that. What we're looking at is, do height and weight have a correlation in terms of total stat? So what I would like to do is basically do a correlation like this between, I don't know, total and, for example, height, right? But I'd like to do it with height and weight. And the issue with that is that they are not normalized, in the sense that they are, how should I explain this? They are non-normal values because they have endless bounds. And I can show you what I mean by endless bounds. The min for both will probably be like 0.1 or something. But the max values are very different. You see? Oh, we can take out the total, sorry. So you can see the max value is 999 for the weight. That's chunky Pokemon right there. But the max value for height is only 14.5. This meters and kilos, by the way. So we have a bit of an issue because we somehow have to make a reference for each. And the way that I would do that is basically saying a value between 0 and 2. And the way that I get the value between 0 and 2 is by doing a spread. So if I have a serial, height, weight, and total, what I would do is then calculate and say the height divided by max height of the data set, right? Which we know is 14.5, is the, let's call it height coefficient or percentage. Why is it? Okay. So basically, for example, they are at 30%, 80%, 50%. Oh, 1.6. That's interesting. I thought the max height was... Oh, sorry, yeah. Sorry, I'm looking at the raw values. So yeah, this is at 11% of the max value in the data set. So basically the height co will be between, it will be between 0 and 1, right? And if I do the same thing with the weight, then I have the weight divided by 999.99. This was the max weight. So I have a weight coefficient as well. And so this weight, for example, 260 is 26% of the max value. Okay? This is almost, it's almost a one-to-one because of 999. But that's fine. So what we want to do now is across all of these different Pokemon, we want to see if the coefficients of these two are coefficients is probably the wrong term, but we want to see if they are correlative or correlated. So we take the height, CO, the weight, CO, and the total. And this I'm just going to do as a nested, as a subquery, just like that. From, I'm going to call this T1. So I've just done a little subquery. Basically means I put this query inside a from statement, rather than doing the whole common table expression and all that jazz. We just do here, we just do correlation for height co plus weight co. We could divide these by 2, which will give us an average of the two. I think we have to put this in brackets. And total. And they are 58.7% correlated. What does that mean? It basically means that they are slightly correlated. So correlation of 0 means they are not at all correlated. In terms of understanding correlation, if you're here for the first time or have not heard the word correlation before, it just means how similar are the two data sets to each other. And so what I've seen is that now a correlation of 58 or almost 59% is not very correlated. Like if we saw, for example, two data sets that were very correlated would be occurrence of rain by day and purchases of umbrellas by day. If we put those two on top of each other, I would assume that they are highly correlated. We're talking 90 plus, right, percent, or 0.9, right? So in this particular scenario, the height and weight are not so correlative with the total. What is, for example, highly correlative with the total would be, for example, the attack value, right? Because the attack value is a part of the total. So if we put attack in here, we should actually see the correlation be very high, which is 74, which is highly correlated, right? It's not very high, but it's high, right? We won't see a correlation of 1 because we've only taken one value in here. But if we took attack plus defense and so on, if we added them all together, it would be correlation of 1, obviously. So basically, coming back to this slight correlation here. Sorry, I had to catch my breath there. I like 0.5869 correlation between height, weight, and total basically tells me that when selecting my Pokemon Dream Team, figuring out height and weight using height and weight as a factor in selecting my team is not going to be that useful. That's what it's telling me. There are probably other things that are more useful than doing that, than using those. So maybe we can find a few other things in the dataset that are more useful. I don't know. We could look at a couple other things. I mean, the legendary flag, for example, we could just do like this. Legendary flag. So legendary flag is 0 and 1. Legendary flag total 40%. It's much less than I expected. So we'll do 0.4023. I saved these queries afterwards, which is why I'm writing some notes up here. So we'll do legendary flag total. And I think, I mean, some of these things are a bit surprising. This is a very low correlation. I would have thought legendary would equate more to the total. What is maybe interesting would be generation. We could also take a look. Generation. Not at all. That's a great example of something that is irrelevant. So here, the correlation between generation and total is basically 0, which means that selecting a better, like we don't need to select later generations of Pokemon to have a better team. That's what it means. Which is also something I would not have assumed in the first place, so that's good. It confirms one of our assumptions. This dispels an assumption I had. I thought height and weight would have more of an effect on the total. Legendary is also a little bit surprising, but I guess just being legendary isn't everything. It also has something to do with the type. Maybe we could just do color just for giggles. I don't know. I hope the color doesn't have a strong correlation, because I don't want to pick Pokemon based on color for my team. Hello? Why is that not? Oh, right, sorry. We can't correlate color because it's not an integer. If we wanted to do that, we would have to translate the colors into numbers, which we can do. Why not? Easy way to do this. Select distinct color from Pokemon Pokédex, right? Now we get all the colors. There's 10. Easy peasy. What do? We say case when. Start down here. color equals, then we have a value, then 1, else null, that's fine. And what we do is we just expand the color selection into these when statements. Oh, that's a bit weird. Also, the playlist is a bit odd. I expected it to be a bit different, so I'm just going to change it. I hope that's okay with all of you. If not, I'm very sorry. From the bottom of my heart. So we have, I'm going to keep the name color. So 1, 2, 3, 4, 5, 6. Wow, that's really not. 7, 8, 9, 10. It's really not cooperating today. Come on. Oh, actually, we don't need these commas. That's my bad. So when we're going to end color. There we go. So we have these 10 colors. Just so we don't forget. Copy them again. So what we do with the 10 colors is, for example, you can paste them here like this. So you have this color which you don't need, right? Now you have all of these values. You just take them out of the clipboard, and if you can get all these aligned nicely, then what you can do is just go with your option key and put them down here and then paste them in. Oh, that didn't work. Come on. Whatever, we're just going to type them out. There's only 10. If you need to do this with like 100 values, then you should probably do like some kind of lookup table or something. But this is a bit easier. With just 10 values. Pink. And if you've been on my streams before... Oh, sorry, Svenne, I didn't realize you'd written in chat. What about single dual type? In the histogram, it seemed like single types are weaker. We could definitely look at the correlation for single and dual types. Absolutely. We can redo them, no problem. Purple, red, white, yellow. I'm just doing a stupid thing with colors now. Which just wanted to do. So basically just translate these into numbers. It's pretty arbitrary. And we need the total in here. So is the color correlated? No, it's not. Does it surprise anyone that it's more correlated than generation? Maybe. That's a bit odd. But we did also arbitrary color selection, like maybe black should be 100 or something like that, but yeah. Whatever, that was just an exercise. So I think it's worth revisiting what Svenne said here about the legendary flag, for example. So what we would do is have the case when type cleaned like slash, then dual, else single, and like this. And then we do type pk. Come on. Oh, my fingers are failing me. And then we do legendary flag. Yeah, and we need to add our group by at the bottom, which is so common. Okay, so for Svenne, to answer your question about single dual type, at least for legendary flags, With dual types, it's slightly more correlated. We could do the height weight again instead of legendary flag. If I remember the values. Height divided by 14, was it 14.5? 13.5? I need to select it again because I don't remember. Max height, max weight. Ah yeah, 14.5. This is height CO. And weight divided by 999.9 is weight CO. And then we do height CO plus weight CO. And we can do the easy one. Instead of divide by 2, we just do average. Oh, that doesn't work? That's interesting. We just do normal math. Okay, so the difference is marginal, to answer your question, Sveni, which is a good question, by the way. Single types tend to have a slightly higher correlation between the total versus dual types, but not significant enough to really say that it's necessarily better or weaker. So what you said in chat, in the histogram, it seemed like single types are weaker. Let's just clarify something very quickly about that. Single types occur more often in the game, and in terms of damage they take from types of attacks, they are more likely to take relatively benign damage amounts. Not all of them. Like we do have ground rock, for example, which is a double whammy for like electric attacks, for example, I believe. Or ground rock. Let me just take a look here. Ground rock. There we go. So it has against, oh, you know what, we should just pin this first row. Look at that. Ground rock. There we go. So the reason that ground rock is not good is because grass, it takes quadruple, and water, it takes quadruple. So that kind of it has a double, yeah, it has two that are two-factored damage. So I wouldn't necessarily say that single types are weaker because you get more of them in the game. They're more likely to occur. So, yeah, it's tricky. By definition, they're not weaker. They're sort of balancing the game. The stuff that you see on the right, sort of where this curve does the bend, I would say from around Poison Rock, around there, around here now, where my mouse is, that is where the sort of bend in the game is in terms of occurrence of these Pokemon, in terms of distribution of the types, not how many there are necessarily in absolute terms. But I think single type Pokemon, yes, they tend to be a bit more simple, but they're also a bit easier to foresee what's going to happen. They're less susceptible to attacks than dual type Pokemon, but dual type Pokemon, by their very nature, I think, can be much stronger. But again, the attacks that Pokemon do are independent of the Pokemon's type themselves. This is another complication that can happen, or a complication that is in the data set that we don't see, is that the attack type is independent of the Pokemon's type, which means that in theory, you could have a fairy ghost Pokemon doing a normal attack, right? And then the other Pokemon being, I don't know, for example, normal water, the normal attack is just going to do where is it? So normal water, the normal attack is just going to do normal damage, 1. That doesn't mean the normal water Pokemon is necessarily at an advantage or a disadvantage, right? But that's that part. So in terms of correlations, we could do also perhaps a correlation matrix one day. I'm not prepared to do that today. I haven't really spent enough time looking up how to do it in SQL. It's something that you see quite commonly in Python or R, these correlation matrices, which are essentially, yeah, if you follow the diagonal to 1, and then you can see which variables are strongly correlated to which other variables. Might be very useful, might also be not very useful. But yeah, I just need to take a short drink, and then we'll continue. All right, so the last thing I think we're going to do today, as we're drawing up on that sort of 2-hour mark, and it is a school night, ladies and gentlemen. It is a school night. The last thing I would want to look at today is if we can build a dream team in some way. And this is a little bit exploratory because I haven't thought about how I would do this yet. So we looked at the type classes. We looked at these capture rates, which are evenly distributed. I would say, could say the average capture rate. Maybe it's not evenly distributed. Oh, I wanted to do it by type cleaned. So order by 2. So I would actually like to include what we did before into this analysis with the 1 minus 1 0 version, because, well, an attack doing double damage to the Pokemon is also pretty nasty. Maybe we should be taking that score in itself. So maybe we could do that. I want to do that purely in SQL this time. So I'm just gonna copy this because I don't want to use the same query again. I mean the same query console. Can we build a dream team? What are people's feelings about building a dream team? Because I know there's something we have to look at, which is the capture rate, because that will determine how easy it will even be to get our dream team. And we need to look at the experience. So there's a, let me just clear this. There's a value here, experience growth. This column determines how fast we can level the Pokemon to level 100. This is very, very, very different. The spread of the experience growth is very different. Let me just show you. Distinct experience growth from Pokemon. So this is the spread. And you can see like 600,000 per, I guess, per level versus 1.6 million per level. In the documentation, it says that experience growth is the experience growth of the Pokemon. Great. That doesn't tell me that much. Basically, when a Pokemon is defeated in battle, it gives experience values to the Pokemon that participated in the battle against it. And those experience is like effort HP, attack HP, etc. And actually we can see those over here. So base experience, if this is defeated in battle, it gives 173, right? I think experience growth is probably how much it needs in total to reach level 100, because otherwise that seems like way too much. 600,000 divided by 173, for example, is 3,500 Pokemon defeated. Really wondering what that means. But definitely this capture rate we have to consider, because low capture rates means it's going to be way harder to at least outright capture these Pokemon, right? So if you're still here, we're almost 2 hours in. I'm going to be looking at assembling a dream team of 6 Pokemon. And I'm not going to talk too much probably for the next few minutes, because I'm thinking about how to do it. One aspect I want to consider is this type class, which we did, which is basically if they have advantage, it's -1, but I want to use the raw values. I think this 1 -1 is not the best approach, because it doesn't account for these kind of double whammy situations. Where, I don't know, like a rock ground Pokemon takes quadruple damage from fighting attacks, right? Basically, I want to have a team that's impervious as much as possible to damage, but could also technically hit hard, and that depends on the total stats, because that, I mean, it depends on the attack stats, right? But the total stat is everything. So that's also their health and the attack and defense, etc. So I could just consider the attack and special attack, but I think that's very narrow view of in terms of assembling a team. I want it to be really good, so maybe I don't need to look at defense. I'm just thinking out loud at the moment. So can we build a dream team? Yes, we can, as Obama would say. First thing to do is figure out what are we going to do here. So type class. This is probably not type class anymore. So one thing I want is I want the type cleaned. I want all the stats. This is like my data frame, basically. So let's say data frame. I want HP, I want attack, I want defense, I want special attack, special defense, speed, and the total. And it should be that all of these added together is the total. We can do a quick check on that. If you're still here, congratulations on making it this far. I typically stream, I would say, twice a week, sometimes once a week, but the Mondays are the regular ones. And then there's a second one. So yeah, these are equal. There's a second stream I do later in the week, typically Friday or Saturday. But it's not fixed slot because it's changing all the time, and sometimes it doesn't happen. So if you are here, that's great. Let me know what you're interested in as well, why you've joined the stream today. I'll probably be doing another 20-30 minutes, and then we'll be calling it a night. As I said, it's a school night, so can't stay up too late. But I'm going to try and start building my team out. Max 6 Pokemon in the team. There are certain situations online battles where there's like a team of 4 or 3, but the classic team is 6 Pokemon. So that's what I'm going to go with. Yeah, and let me know in chat if you have questions or something. I'm not going to probably talk so much during this next bit because I'm trying to figure out basically what I want to use, what do I want to base the team on. So I need these against features. Can I just copy them from here somewhere? I didn't keep them, did I? Oh, here we go. Against bug, blah, blah, blah. So these are all my features now. What do I have here? Limit 10. So I have my Pokemon type. Oh, we're gonna need more. We're gonna need the serial. Otherwise we won't know which Pokemon it is. There we go. So we have each Pokemon with all of their specific things. Alright. So the first thing I'm gonna do is let's do maybe stats spread. So what I'm thinking is maybe spreading the attack in terms of purely taking the top tier. If I look at attack and special attack and speed, those are the 3 I want to focus on, because I'm going to focus on, based on the against values, taking something that hardly ever takes damage, or when it does take damage, it's less likely to take a lot of damage, let's say. Sorry, it's not about the frequency of the damage, it's about the likelihood of it being savage attacks, basically. And then in the stats, I can focus on the attack, the special attack, and speed, which means it's more likely to hit hard and fast. And if it does get hit, it still has this good against values. That's what I think I'm going to try and do. And so for that, I'm going to do a stats spread. So common table expressions are a bit funny, but basically you can just create as many of these as you want. And it's a wonderful way to spread the logic over multiple queries, rather than doing subqueries where things get a bit convoluted, to say the least. Need to take a short drink again, sorry about that. How do we feel about music? Are people enjoying this sort of dubsteppy stuff? Or should we have something a bit more trancey? You tell me, chat. I'm open. Just not country, please. Oh, you don't hear the music? Okay. Then I will bump it a little bit. Let me know if you hear it now. Is that a little bit better? Some of the tracks are a bit quieter than others. Interesting. It does show me as music coming through, so interesting. I hope it's not the case that you don't hear the music. This would be very boring with me just talking for 2 hours. I wouldn't want to listen to myself talking for 2 hours without music. So feel free to put on your own music next to it if you don't hear mine. I'm sorry about that. I was testing out this new solution with pretzel rocks, but I would have assumed that it would be working. So the stats spread, what do I want to do here? I want to account for this against issue. So I want to average out these again like we did before. And the way I'm going to do that is by cheating. No, it's not cheating. It's basically saying 18, or rather the sum of these, which I need to now remove the comma. Oh wait, let's do that first. So what I can do is do multi-line selection, like this, right? Then we can do, nope, that's the wrong one. I will find the key combo in a second. Let's start this way, it's better. So I have multi-line selection, and now I have everything selected, and I do delete, right? And this deletes everything on that line. And then I can actually take these again. I can take, because they don't have any commas anymore, I can just remove those. Oh man, this is annoying. So I need to replace this with a plus, like that. I think we'll just do the formatting, because it's going to be too tricky otherwise. Okay, that more or less works. Like that. Where are you tuning in from, ZDataman? Get people from all over the world in here. Got people from Russia last time. Guess it always a bit depends what time zone, right? Jesus, why is this? Oh, I made a small mistake here. Okay. Against poison. It's a bit of a long query, I know. But I want to sum all of these fields, and there isn't really a different way. So what I want to do is do the sum of these minus 18. Oh boy. From stats spread. Wonderful. And I'll need to do a group by here. Oh yeah, okay, how many fields do we have in here? 1, 2, 3, fine. I will take these out. Do it this way. Oh, it's formatted that nicely for me. Sort of. Group by 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is fun. We need to name this. This is called the damage. I'll call it coefficient. It's not really a coefficient, but sort of. Is it the same as an average? I feel like it's the same as an average, but is it? Oh, it really is, huh? It is an average, because of course I'm doing 18. Ugh, terrible. So this is the average damage factor, 1.25. Doesn't account for all of them. But we could do like, I don't know, if we did min max, would be kind of interesting. It's not quite the same thing, is it though? Let's run with average for now. Minus 18 gives me the average damage factor. And basically what I want to do with this, so I have a Pokemon Grass Poison which has the following stats, and average damage factor is 1.25. Anything in a negative area for damage factor will be very good, right? Because it means they'll take less damage. Let's try to just see if there's any cases where that's the case. Less than 0. So for example, this Pokemon, which is Dragon Steel, 4831. So let's do serial equals 4831. It's Dialga. Alright. Temporal Pokemon, Dragon Steel. It has... Let's just check. Against Bug, 0.5, 0.5. Fight does decent damage against it, but Flying and Grass are less than average damage. Yeah, it's getting a lot of benefits here from a lot of different types. That checks out. So that's good. That seems to make sense. Alright, so these are this is like my best selection so far, but I'm not going to only look for these ones, right? That's very simplistic. That's just Pokemon who are less likely to take, are likely to take less damage when hit, based on those attacks, right? Based on all those different attacks. It doesn't account for the spread of how common those attacks are. Obviously there's more normal moves than psychic moves, for example. But the likelihood of someone using each one is technically equal, right? We can assume that in a battle, any Pokemon could come up. They're all equally likely to occur, these attacks. That's why I'm looking at it that way. So my stat spread here is, for the moment, we have Grass Poison Pokemon. It's 1.25, for example. So if it does get hit, its tendency to take a little bit more damage than normal. 0 would be completely normal damage. What we could include, besides the type cleaned, is also the dual single type thing, because maybe we should have an easy selection there. So we'll do type cleaned like %/%, then dual. We used this before, right? Else single, and type, PK type. Oh yeah, we need to add that to the group by. So we now have dual type and single type Pokemon in here as well, just in case we need to filter by that later at the end when selecting our team of 6. So, next thing to do, attack, special attack, and speed. We want to do attack plus special attack. Plus speed. We're going to call this the rect total. It's not a very good name. I mean, I think it's a very good name. It's just not a very accurate name. People might not know what it means. Basically, the rect total means how high is their wrecking ability, right? So attack, special attack, and speed will determine how fast they strike in a battle, and if they can block and things like that as well, I believe. With speed, I'd have to read up again on the mechanics. But basically, if we had this kind of information, what could we do? We could do... we also want to work out not only the rect total, but also in which spread they are. So we'll do... We have to figure out the bounds of these, and then we can figure out a bit more. So we'll do... So I want to figure out, for example, if these Pokemon are like in the top 1% of this value. But I mean, maybe we don't need to... We could do that. We could rank. Could rank them. Rank over rect. Rect total partition. Oh, I'm writing this wrong. Rank over Postgres. Just need to look up the syntax because I got this wrong last time too. Rank over. Come on. Why are there no good examples? Do. Wonderful. Blah blah blah. So this is like the syntax of this thing. Rank over. It's like this, for example. So rank over. All right. Partition by serial. Are you guys enjoying the stream today? Chat's very quiet today. Let me know if you're enjoying the stream today. I'm having good fun right now. Rank over partition by serial, order by... Seems like we have spam in chat. Wonderful. Trying to remove this from chat and I don't know how to do that, so just bear with me. So I don't know how to actually take that out of the chat feed. If someone knows how to remove that, welcome to tell me, but I actually don't see it in mod view right now. Which is very unfortunate. I'm just gonna look this up very quickly. Oh, I think it's because my view is a little bit messed up. Mod icons. So I'm just trying to delete the spam in chat, and it's not so simple, it seems. I thought it would be a lot simpler, but it seems not. Here we go. There we go. Problem solved. Sorry about that. That was a bit annoying. Back to our task at hand. Partition by serial, order by rect, total. Descending. And this is the rect rank. So what this does, if I can show you this, you can see here the, where is this rect score? There's a rect score somewhere, rect total. They get a rank based on their, okay, so, oh right, I have to partition by rect. And then they get a rank for their order within the list. But I see that it's not working specifically for each one. Why is that? The rank should be different. I think I need to do both. Is that right? Rect total and the serial? That's odd. I'm not sure why. I should be able to rank that. Maybe if someone sees what the issue is. I was pretty sure I would be able to rank them. Maybe because there's a limit? No, they're all rank 1. That's not right. Well, it's not that important because I'll just take the max anyway. I mean, basically, if I have a stats spread now, right, I will basically say order by rect total descending, where average damage feet is less than 0, for example. And this gives me 195 Pokemons to choose from, which is super cool. That's actually pretty awesome. Order by rect total and average damage foot, or whatever we want to call it. That doesn't quite work. Ascending. $398. So if there were, yeah, so basically we can choose from these two values, also with total. So this is kind of cool. So total desk, basically these would be the top choices for the team. However, we have something else to consider. We also need to consider that we should have different types of Pokemons in our team, which makes things a little bit more complicated because we can only select, for example, one of each type. So let's see. And the HP value also makes me slightly concerned. I want to get the spread of the HP to know if I'm in the top tier of the HP values. So I need to know what max min HP is in the dataset. Select star from Pokemon Pokédex. Min HP, max HP. Min is 1, max is 255. Beautiful. So what we do is we do HP, and then we do HP divided by 255. And this is max HP. Oh, wait a second. We have to include this towards the end, otherwise it's causing issues with our group by statement. So now we have this max HP value. I should round this because it's causing issues. To 2 decimal places. That's good enough. That's funny. So we have serial, type cleaned, PK type, max HP. Oh, we should include the total in here. Total, max HP, rect total, and the average damage. Alright. So these are the preferred Pokemon because they're -0. They're less than 0. We could do actually equals as well. Would give us a bit more flexibility. We want to basically tolerate normal damage or be at an advantage. The stronger the minus, the more in the negative, the better our chances. So we do have an issue is that 453 Pokemon is too many to choose from. So this is better, less than 0. 195. We have basically totals the strongest. However, we know the rect total is very important because that is our hitting power, if you will. Let's call this hit power. And HP is funny because that's actually health points, but that's why I'm not calling it HP. Oh, yeah, I forgot, sorry. Hit power. So essentially, if you just took these 6, you'd be doing fine, but they're the same types, and there are some restrictions in terms of what moves they can learn and all that kind of stuff. Yeah, definitely something to think about. Oh, I need to think about this. I don't know if just doing the data selection is good, or whether we should be doing something more advanced with like a seeing where they land. Actually, what we could do, just for a good thing for the end of the stream to do, because I think I'll be calling it a night shortly after this. What we can do is run this in Metabase. Doing science. Okay. We should have 195 rows from this. Just gonna change up the music to something light for the end. What should we put on? Maybe Surprise Me. Wow, this is taking a long time. Let's try this again. Postgres, Pokémon. Okay, that looks good. Write SQL. Run. Oh, that was much better. So, I hope this isn't too small for you guys to see. I actually don't know how to increase the font. There we go. There we go. Scatter. Bubble size. Hit power. X-axis. Max HP. And the average damage. Oh wow, okay, it's messing with the visuals, so I need to zoom out. This is very cool. We can add a breakout for the max here. We could say this is the Pokemon type, for example. So the singles are blue, and the dual type Pokemons are yellow. Who else thinks this looks pretty cool? I think this looks insane. So max HP is basically, that's safer. If we wanted to pick 6 Pokemon, we should technically pick along the spread, right? We should pick along the spread. If we pick all of them from down here, then we basically have a fairy steel, a fairy steel, a flying steel, a dragon steel, a fairy steel, etc. And that's bad because we should not have 6 Pokemon of the same type. So the occurrence of the type, ideally, I think should only happen once. That's my point of view. Instead of doing type, we could do the type cleaned. I think it will break the chart a bit. Yeah. You see, like, this is a bit harder to read. But generally speaking, we can assume that we could take one steel Pokemon, this one here, 8081. That seems to be a very good Pokemon. We could take, these are all steel. God damn. And I know what we could do. We could select one of the types and then filter that out progressively. That could be cool. Chat, what do you think? Should we maybe do it that way? And then we could have a tentative team already for today. And we could float that team to one of my colleagues who knows a bit more about Pokemon than I do. And see what they think about that team. I would try and do that. I mean, I would want to take the best steel that there is. Basically, this Pokemon is Flying Steel, and it has really good HP. So 8231. 8231. Which is Flying Steel. So now we say and type cleaned, not in, because we're going to have multiple conditions here. And this query, I'm going to paste it back into DataGrip afterwards. I'm just going to continue writing it here. Type cleaned, not in, Flying Steel. Flying on its own, and Steel on its own. Re-execute. Oh, that's not good. Multiple result sets. I think it doesn't like comments. I think I found that before. There was some issue with comments. Yeah, so what we're gonna do is just take these comments out. And in the background, I'm gonna annotate this stuff in DataGrip. I mean, update it. There we go. So, Flying Steel, Steel and Flying are out. How come I can't make this smaller? Jeez. Yeah, so what's next? Oh, I see, yeah. We need to do a not like instead. Not like Steel and wow, the auto completion here is way worse. Flying is the ones we took out, right? Flying Steel. Okay, let's re-execute this. Okay, so Flying and Steel are out. This makes the selection process a bit easier. So there's a nice Dark Poison one there, but there's a Dark Ghost. Let's compare. So this one has like 40% of max HP, 248 hit power. Where's the hit power on this? That's the bubble size. This one hits super hard. This big boy here, 256. That's massive. Electric Ghost. That's a big boy. Let's take that one. 4795. Electric Ghost. Right? electric ghost. So we're gonna do and I should just copy these. And electric and ghost. Getting closer to that dream team as we take out these types becomes easier to select, right? Progressively. And then we can just include R6 serials afterwards, and that's going to be awesome. We're going to see our dream team in action. So, what's next? Dark poison. Dark poison, dark poison. Those seem to be real outliers, apart from this fairy normal out here, which we could also take. So this one seems to be the best choice based on the max HP. 4351. I don't know which Pokemon these are, by the way, because they're so abstract with the serial. That's a dark poison. So we want to have dark out and poison out. Rerun the query. Alright, it's getting easier. Let's see. This fairy normal seems to be a logical choice, but the fairy type here is a single, which has 680 total. So it has hit power 361. This one only has a 200 hit power. So that small spread of 0.5 damage, I think is offset a bit by taking a bit of a more aggressive Pokemon. So I would take this 7161 single type fairy. 7161 fairy. Yeah, and then I'm gonna take out fairy from the deck. This is just assuming that we're not doubling up on types, right? We could of course double up on types. Wow. Okay. That was interesting. So there's only one left. 7211 fire water. What? A fire water Pokemon? No way. That's nuts. Holy crap. Literally exists. That's pretty nuts. So that's 7211. Fire water. Well, okay, if we take those out, doesn't really matter now because we have no Pokemon left. Yeah. So what we should do is increase this to equal to 0 for the last one. And then basically choose if we want to have a big hitter or not. So the big hitter would be hit power 210. Oh, the smaller, the higher the hit power? No, that's not true. 275. 275 would be this one. They're all along the same... Oh, we don't need the PK type anymore. But we could add the... Ooh, what should we do? So hit power, max HP. Let's add the total along here. Instead, no, that's the X. Yeah, this one I could add here now. So something like average damage feet and then total. What's this one? 250? 275. 275 hit power. But 30% max HP. It's not great. Something mid-range would be best. Like this one. Yeah, 355 hit power. That's good. Let's do this one. So it's 2891 is our last choice. 2891, which is a normal Pokemon. Yep, single type. So if we were to now include only these, then we would do like we would probably want to write something like this. Serial in. So I just have my notes here. 8231 4795 4351 7161 7211 2891. So these are our 6. Now how do they fare across all of these stats across the entire board? We'd have to select them in the data set to highlight them especially, but I think it's a good selection for now. I don't know if it's really definitive. It's maybe something I would pick up another time, but yeah, it is very late. It's beyond what I thought I would be able to do today. Basically, these are our 6. Oh, that's interesting. Oh yeah, because we said equal to. Exactly. So these are our 6. I would love to know which Pokemon these are. So let's take the name. And let's add the name here. And I've even remembered that I need to update the group by. Look at that. Name. Let's see what Pokemon they are that we've selected. Wow. Oh, Rotom. Awesome. The others I do not really recognize. But if we organize by serial, then we can. So Slaking is Pokemon 289. So that's already like Gen 2 or 3. Past where I was playing regularly, that's for sure. But this would be our dream team. In theory. In theory. There's a lot of caveats to be said about this. There's a lot of caveats. I think the biggest one is that we did a little bit of a manual selection. I'm sure there's more formulas or, let's say, data science-y ways to do this. But what I would say is that having selected manually ensures some level of control over certain variables. So I have, for example, here, really nice spread of hit power. So let's order it again by the order we originally had, right? We have a good spread of hit power. The max HP, so we did over the max value, right? We technically could do the same with the hit power to know if we're in the like top region, but basically we've got like this one has Rotom is a bit weaker, 20%, 40%, 40%, 60%, 50%. So they're fairly good in terms of just having enough health, right? Good total values, which is necessary. 2 are singles. 4 are duals Pokemons. They have good hit power. We saw that. I mean, we saw that. I don't know what max hit power was. We could work that out. Select star from Pokemon. Let's see what max hit power is. Max of these 3 is 510. So if we do this divided by, oh wait, I want to keep that, sorry, and just do another line and say this plus this plus this plus this divided by 510.0 is hit power percent, or I don't know, max hit power. And we're gonna round as well, why not? Round this to, I don't know, 2. So we could do here the max hit power. So yeah, they're generally speaking in the 70th percentile. These are a little bit less strong, but they compensate by taking way less damage, normally speaking. So Corvic Knight, for example, Flying Steel. There's very few attacks that are going to do serious damage to it, but it has still decent hit power and decent health. This is my team. Let me know what you think about that. If you're watching this on YouTube or in a later VOD, in a recording, let me know what you think. I'm going to end the stream here, and thank you for watching today, bearing with me while I learn as well. If you have any suggestions at all, please put them in the suggestion box in my Twitch profile, or write me a message on LinkedIn, or write me a message on Twitch. I'd love to know what you thought of today's stream and the other streams if you've been watching them. And I hope to see you next time on here in chat. Will be really cool to interact with you again. So thank you and good night.